Hello, good morning again, class. So our new topic is three-moment equation. This is applicable for finding the response of a continuous beam. Pag sinabing continuous, it has three or more supports. Okay, so ang technique natin dito ngayon, mag-start tayo sa problem 20.2 kasi itong 20.1 symmetrical siya. Sa 20.2, it is unsymmetrical. And then, as we go along the problem, i-compare natin yung mga problems, kung anong common features nila, kung ano ang common steps, and then also, ang goal natin dito, as the same with the previous methods, is meron tayong step or pattern na sinusundan. Okay? Para hindi tayo basta-basta malilito. So we have here 20.2. Analyze the continuous beam shown given ang kanyang dimensions tsaka yung loads. Okay? Initially, dimension tsaka loads ang given. Yung mga reactions, sosolvin mo yan. So, sa step 1, always determine the end moments. Kapag sinabing end moments, yan yung cantilever sa dulo. Okay? Like example for this figure, yung end moment 3 is equal to negative 40 times 2. So, negative in the sense na downward siya. Okay, so irregardless of the direction ng rotation, basta downward, negative. Okay, so negative 80. Tapos, yung M1, since this is simply supported, ano siya? 0. Okay? And then, meron tayong note dito. Moments due to cantilever loads are always negative. Okay? So, that is yung load pababa. And then for step 2, determine the values of 6a small a all over L and 6ab all over L. And then meron tayong table 20.1. So let's look at span AB. Ang technique naman dito ngayon, ang span is the distance between supports. So we have supports A, B, C. Ang first span natin is AB. So yan ang L1. Next span is BC. Yan naman ang L2. Sa AB, meron kang load na 50. And then, ang i-consider mo dito yung exterior end. Okay, so that is at A. Ang value ngayon ng 6A1, small a1 all over L1, pupunta ka ngayon sa table 20.1, which is ito. Hanapin mo ngayon yung kaparehas niya na figure, which is ito may concentrated load ka at within the span. So ito siya, case number 1. Ngayon, ang kukunin nating equation is yung nandito sa dulo, okay? Which is, ayan, A, yan. This is A, tapos ito naman yung end B. So ito ang ating equation. So, P A all over L times the quantity L square minus A square. Okay, so your P here is 50, tapos yung A, that is itong distance na yan. Whether it is greater than B, ito pa rin ang iyong value ng A, nandito sa end. Okay, so ang iyong A ngayon ay 2 all over L1, which is 5. Note that L1 is always the distance between support. And then you have here L square minus A square. So that is equal to 420 kilonewton meter square. Next let's now go to span BC. Ito naman, mapapansin nyo na dalawang concentrated loads ka. So, dalawang equation ang gagamitin mo. Actually, isa lang pero uulitin mo siya. This time, gagamitin natin is 6AB all over L. Meaning, dito na tayo sa kabilang N. So, for the 35 kilonewton load, ang kanyang A would be 2 plus 3. Okay? Take note, dito tayo sa N. Dito, no? So, 35 times 5 all over the length na 7. So, that is 2 plus 2 plus 3. All over 7 times the quantity 7 square minus 5 square. And then, plus in the sense na meron kang 70 dito. Okay, so that is 70 times 3. Bakit 3? That is because yung length niya, which is small b, is now 3, no? So that is 70 times 3 times the quantity 7 square minus 3 square all over L. And that would be equal to 1800 kilonewton meter square. Note, H1 and H3 is equal to 0. Yan yung vertical displacement. Ano? Kasi kung minsan yung support mo, merong displacement. At pag nag-displace, meron yang equivalent force. For this problem, 0 ang ating H. Tapos, yung kanyang moment of inertia is 1. Initially kasi, hindi given yung moment of inertia dito. Kaya, gagamit ka ng 1. And then for step 3, ito na yung general equation ng 3 moment. Okay, so for a 3 moment equation without displacement, this is m1 L1 plus 2m2 times the quantity L1 plus L2 plus m3 L2 plus, ayan na, yung sinolve natin kanina. Next is, you substitute yung mga na-solve natin. So, note na your M1 from step 1 is 0. Okay? Tapos, yung M2, that is the moment at the middle support. That is always unknown. Okay? Laging yan ang unang unknown, yung moment sa gitna. And then, M3, yan yung na-solve natin, which is negative 80. Tapos, itong 6A1 all over L1, ito yung 420. And then, ito naman, yung 1800. So, equate that to 0, and you get a value of negative 69.167 kilonewton meter. And then, finally, step 4 is you solve for reactions. Okay, dito tayo ngayon sa cut at point B. Okay, so cut section at point B. Wait lang. Ito siya, no? Cut section at point B, and then consider the left section only. So dito, ito lang. Ang kukunin nating reaction is R1 tapos yung 50 na load, which is ito. Yan. Okay? So, remember na yung na-solve natin na M2 is 69.167. So, summation moment at B is equal to M2. Okay? Ngayon, pwede mo ring gamitin summation moment at B is equal to 0. Pero kung i-equate mo yan sa 0, dapat isasali mo pa rin si M2. Obviously, in any beam, summation moment at a point is always 0. Kasi pag may moment ka sa kanan, ganun din ang moment mo sa kabila. So magka-cancel out sila. Okay, so 5R1 minus 50 times 3. Yang 5R1, take note, yung dito tayo nag-take moment sa point B. Yung R1 would cause a clockwise moment. Take note, sinulat ko dito na clockwise direction is positive. Minus 50 times 3. Yan yung load na 50. Ito, ang lever arm niya ay 3. Is equal to M2. Okay, so your M2 is 69.167. So from there, you can solve now that your reaction 1 is 16.17 kilonewton. Next is you cut section at C. Left section naman ang i-consider natin. So, dito tayo magkakat ng section and you now consider the left part. Meron na tayong R1. So, ang unknown mo dito ngayon ay R2. And we have the vertical loads na 50, 35, and 70. So, let us isolate the figure. Ito siya, no? Ayan yung R1, R2, tsaka yung tatlong loads. So, summation moment at C is equal to M3. Note na si M3, that is equal to negative 80. Okay, so 12 times R1. 12 is yung lever arm nung R1 from the cut section. And 12 R1 is positive kasi clockwise rotation siya. Plus 7 R2, positive na naman yan kasi clockwise rotation. And then yung mga loads multiplied by its lever arm is equal to M3. Okay? Note na si M3 ay negative. So from there, you substitute the value of R1 dito sa equation and what is left is R2, which is 87.29. And then finally, we will now cut section at B. Take note na ang nasolve natin ngayon ay R1 tsaka R2. What is left now is to solve for R3. To do that, we will cut section at B. Okay? Yan. Cut section at B. Right ang kukunin natin. So, dito tayo. And we have reaction 3 plus yung vertical loads. Yan na. So, ito yung kanyang figure. Remember that this is moment 2. This is point B. Okay, dito tayo nag-cut sa point B. So, clockwise direction again is positive. Yung loads mo ngayon ang magiging positive direction. So, 35 times 2 plus 70 times 4 plus 40 times 9 minus 7R3 is equal to moment 2. Okay? So, yung moment niya ngayon ay 69.167. Bakit this time naging positive? When in fact, yung nasolve natin ay negative 69.67. Okay? Kasi, yung 69.67, ang ginagamit natin dito ay yung left section. Okay? This time, right section ang gagamitin natin. Kaya, magiging positive naman yung moment mo ngayon. Okay? So, obviously because it becomes opposite direction. So, from there, masosolve mo ngayon si reaction 3 and then you check. Summation forces vertical equal to 0. So, reactions pataas tapos yung loads pababa. 0 is equal to 0. Now, let's look at problem 20.1. Ang requirement ni 20.1 is find the change in bending moment at the center if the center support settles 12 mm. So, dalawang approach ang gagawin natin dito. The first is walang settlement. Second, yung merong settlement. Notice na this time, meron ka ng moment of inertia tsaka elasticity. So, still yan, no? And then, also, ang kanilang L1 tsaka L2 parehas. And also, uniformly loaded on both spans at 20 kN pareho. So, Step 1 is to find the end moments. So, at point A and point C, obviously that is point 1 and point 3 also. So, moment 1 is equal to 0. Moment 3 is also equal to 0. And then, step 2, we now find the values of 6AA all over L. So, let's look at table 20.1, which is ito. So, ang kanyang equation is WL cube all over 4. Okay? So, ito. Yung ibig sabihin ng small w, ang unit niyan ay Newton per meter. Okay? So, WL cube all over 4. Dito na tayo. So, ang values mo, meron kang 6AA all over L sa node A tsaka sa node B. Pero, kukunin natin yung exterior lang, which is at point A. And that is WL cube all over 4. Yan. So, W mo is 20. L is equal to 4. And then, you have all over 4 and you get 320. And obviously, that is the same with span BC. So, that is also 320. And then, dito, sa first approach, your displacement is 0. Pagdating dito sa next approach, ang displacement mo meron na. Ayan. H1 is equal to H3 is equal to 0.012 meter. Okay? So, 12 mm is equal to 0.012 meter. And then, dito sa right side, ito yung second approach. Yung meron kang displacement na 12 mm. And that is equal to 0.012 meter. Okay, so same procedure sa step 2. Kukunin mo rin yung kanyang 6AA all over L, which is parehas lang sa first approach. Okay, so parehas silang 320 tsaka 320. But this time, sa step 3, yung isa-substitute mo na sa general equation, magkaiba na yung first approach tsaka yung second approach. So, balik tayo dito sa first approach na no settlement. And remember na itong with settlement, ito yung second approach, ano? Magkaiba ang kanilang general form or general equation. Dito sa no settlement, this is equal to 0. Pagdating dito sa with settlement, it is no longer equal to 0. Iko-consider mo na ngayon yung displacement na H1 tsaka H2. Okay? Yan ang kanilang difference. The rest, parehas na ang kanilang M1, M2, M3, tsaka yung 6A all over L. So, balik tayo dito sa first approach. Okay? So, step 3. M1, L1 is equal to 0. Take note, M1 is yung nasa node A. Yung M2 that is unknown. M3 is also 0. Tapos yung 6A all over L, that is 320 and 320. You equate that 0 and your M2 is negative 40. And then, you solve for reactions dito sa step 4. And you get reactions 50, reaction 60, and reaction 50. And you check the summation forces vertical is equal to 0. Okay? Now let's go to the second approach na merong displacement. So, ang pinagkaiba lang nito ngayon, yung isa-substitute na natin si H1 tsaka si H2. Okay? And that is H1 equal to 0.012. Okay, this is H3. So, this is H3 all over L2. Okay? Okay, so, bakit naging H1 tsaka H3? And that is 0.1 tsaka 0.3, parehas na dulo-dulo yan. Pero ang nagsettle ay yung 12 mm. Okay, so let's go back to the book. Ito. So, yung H1, that is the settlement of the support from node 1. Yan, okay? Tapos, yung H3 naman, that is the settlement of the middle support from point 3. So, ibig sabihin yung subscript na yun yung reference, no? Kung saan siya nagsukat. So, H1, ulitin ko, dito sa support, bumaba siya ng 12 mm. Dito, yung H2 naman, from support number 3, so dumaba siya ng 12 mm. So, obviously, ibig sabihin, kung magkaiba ang elevation ng 1 and 3, magkaiba ang H1 tsaka H3 with reference to support number 2. Okay, so let's go back to our problem. So, ibig sabihin yan, you now substitute. Okay, so this now becomes M1 is 0. Tapos yung M2, that is unknown, 4 all over I, 6.08, plus 4 all over I, 6.08 by 10 to the negative 5. And then plus M3, 0 yan. Tapos yung 6A all over L, kinonsider na natin ngayon yung I, eto siya, is equal to, eto na, yung equation na yan, 6 times E plus the H1 all over 4. Okay? So, from this general form, which is this, magkukuha mo ngayon yung 16M2 plus 640 all over 6.08 is equal to 7,200,000. Or your M2 is negative 12.64. So, change in bending moment, that is minus 12.64 minus the original M2 na negative 40. Yan. Okay. So, that is equal to 27.36 kilonewton meter. Our next problem is 20.3. So, you'll notice na 20.2 tsaka 20.3 parehas lang sila in the sense na si 20.2, yung cantilever niya ay nandito sa right. Si 20.3, yung cantilever niya ay nandito sa left. Okay? So, let's proceed with step 1, which is finding end moments. So, you will notice na yung numbering 1, 2, 3, yan yung supports. Tapos, yung lettering, yan naman yung mga ends. So, dito sa cantilever end, that is A. Yung support, letter B, C, and D. Yung 1, 2, 3, yan yung supports talaga. Okay? So, step 1, yung moment 1 is negative 5 times 1. So, basta cantilever, ang downward load lagi ay negative. So, negative 5 times 1 would give you negative 5. And then, moment 3 is 0. And then, step 2, solve na natin yung mga 6A all over L. This time, ang i-consider natin is spans BC and CD for span BC, yan yung gagamitin nating L1. Notice na dalawa ang kanyang load, concentrated tsaka uniform load. Looking at table 20.1, so meron tayong uniform load, ito, case number 2, tsaka concentrated load, case number 1. So, ang gagamitin natin sa case, sa concentrated load is case number 1, wherein A is simply equal to B. Okay, so, ito siya. Para sa uniform load, you have WL cube all over 4. So, we have 4 times 4 cube all over 4. And then, sa concentrated load naman, you have PA all over L times L square minus A square. Which is this one. Ayan. 4 square minus 2 square. It will give you 112 kilonewton meter squared. And then, dito tayo ngayon sa span CD. So, in here, we have a triangular load. Ang i-consider natin ngayon is yung exterior. Okay, so nandito sa point 3, yan ang i-consider natin. Which is, by the way, case number 3 dito. And, etong end na yan, yung mataas ang load, which is 6. So, that is at point B. Okay, so etong itong left, yan ang point A, tapos etong right side, yan ang point B. So, ang gagamitin natin ngayon is 6AB all over L. Ito. Which is 7 all over 60 WL cube. Ito siya. Okay? Yung small w, yan yung 6. Okay? So, ito yun. 7 all over 60 times 6 times L cube. Okay, ito, which gives us 151.2. And then, from there, isa-substitute na natin siya sa general equation or general form. Since wala tayong displacement, yung H1 tsaka H3 is equal to 0. And, walang given na moment of inertia I, so gagamit tayo ng unity, which is equal to 1. So, we substitute everything to our general form. This is M1, L1, remember? No? Negative 5. Tapos, yung L1 is 4. And then, M2 is unknown. And then, you have L1 tsaka L2, 4 and 6. Tapos, M3 is equal to 0. And then, this is 6A1 all over L1. And then, ito naman, 6A2 all over L2 is equal to 0. Ang unknown mo na lang dito ay M2, which gives us negative 12.16. And then for step 4, magkakat na tayo ng section. Okay, so step 4, that is solving for the reactions. Now let's cut section at C. Ito yung figure. Okay, so cutting section at C, dito siya. And we consider only the left section. So, ang i-consider natin ngayon, itong A, B, tsaka C. Ito yung figure. Ang loads, you have the 5, the uniform, and the 8. Ito siya. So, take moments at point C, clockwise as positive, is equal to M2. Yung R1, it will give us a clockwise moment, kaya positive siya. And then, yung negative, and then yung downwards load, you have negative 5, negative 8, and negative 4. Which gives us now the reaction of equal to 15.21. Okay. Notice na this is equal to M2. Ayan, ha? Ang ating M2 is negative 12.16. So, this is equal to 12.16, no? And you have the reaction R1. Next, still cutting at section C. This time, ang ating i-consider ngayon yung triangular loading. Ito ngayon yung ating figure. And that is again equal to M2. Pero, mag-change sila ngayon ng direction. Okay? Dahil kung parehas sila ng direction, iikot at iikot yan. Kung sa dito, ginamit natin ay cut section at C left section, gumamit tayo ng negative 12. Dito naman sa right section, obviously, gagamit tayo ng positive 12 para equilibrium sila. Okay? And we only have here the triangular load tsaka yung reaction. This time, yung reaction mo magkokos yan ng negative moment. Kaya negative ang ginagamit dito. Minus. And yung triangular load, you have 6 times 6 divided by 2 multiplied by 4. 4 is the lever arm from point C. Now we equate that to positive 12.16. So this becomes now positive because of the opposite direction. And your reaction 3 now becomes 9.973. So from here, pwede ka nang mag-summation forces vertical kasi dalawa ng reactions mo, R1 and R3. But let's cut section at B. Okay? Para makuha natin yung reaction na isa, which is R2. Okay? So summation moment at B is equal to M1, taking right section only. Pwede kang mag-take ng left section, pero wala kang masosolve kasi yung R2 ang unknown mo dito. So obviously, we use the right section. Ano? So, yung 8, yung 4, tsaka yung triangular load are all clockwise moments. And what is left na negative, you have R2 tsaka R3. And what is left here is equal to positive 5. Okay? Note na yung M1 originally, that is negative 5. Ano? But M1, that is if you're considering the left, negative. Pero pag dito na sa right section, opposite direction yan. Kaya siya naging positive 5 yan. Okay? Ayan, it becomes a positive due to opposite direction. So R2 now is 21.817. So ito yung figure, and you have the summation forces vertical equal to 0 as your check. So again, ang dinedemonstrate ko dito yung manual solution. Paano nakuha yung mga numbers dito sa book. So, as you can see here in the book, 20.3, ayan, sa figure pa lang, meron na kagad yung reactions, ano? Dito. Pero, hindi niya pinakita dito. Sometimes yung other problems hindi niya pinapakita kung paano nakuha yung reactions, ano? So, yun ang purpose nung solving it manually using hand calculation. Now let's go to problem 20.4. Yan. This time, ang reactions natin apat na. So you have reactions 1, 2, 3, 4. Ang approach naman dito ngayon is dalawa, ano? Meaning, split natin yung beam into two separate continuous beams. Let's say from A to D. Ito siya. Kasi pag A to D lang, coveran mo yan, you only have 1, 2, 3 supports. So you can proceed to steps 1 and 2. Samantalang another additional extra step, you have yung split na beam from point C to E. So you have C, D, E. Dito, similarly, you have 3 supports. Okay, so Ang mangyayari dito ngayon, dalawa na ang unknown moments natin. So, dito tayo ngayon sa A, B, C, D. Okay, so trinit natin si point B to C as your first span, and then point C to D as your second span, L2. Okay, so step 1, ang moment B mo dito is negative 20 times 2. Ayan. And then, moment at point E is 0 again. So, let's go back to step 2 for span A to D. Okay? So, sa BC, 0 ang ating 6A all over L dahil walang load. And then, dito sa CD, span CD, you have WL cube all over I. But what is I? It is equal to 5I. So, meron tayong 108 all over I. And then, for step 3 naman, okay, still here on the section A to D, isa-substitute na natin ngayon yung ating mga values sa general equation. Take note na this is again equal to 0. So, remember na yung ating point D dito sa A to D, hindi to equal to 0. So, merong value yung M3. Okay? So, this is M1 to M2 plus M3 all over I. This will not be equal to 0. That is now your other unknown. Okay? So, meron tayong M2 tsaka M3 equal to negative 8. So, this is our equation 1. Now, let's proceed to the other beam, C to E. So, you do the same procedure. Meron tayong 6A all over L dito sa span CD, which is 108 all over I. Tapos, sa span DE naman, so that is PA all over L times L square all over A square. Ngayon, B pala, no? 6AB all over L times the quantity L square minus B square. Ang ating B would be 4. Tapos ang L is 6. And then your I is 4I. And you have 200 all over I. Again, walang displacements sa support. Kaya ang H1, H3 equal to 0. Now let's go to step 3 of span C to E. So, this is M2, okay? And then 2M3, tapos ito yung M4. And then you have 6A and 6A. And what is left here is 1.2 M2 plus 5.4 M3 is equal to negative 308. So this is now our second equation. So notice now we have here a linear system. Equation 1 and equation 2. So, we have common unknowns M2 and M3. So, solvein natin ito ngayon using matrix methods. Gagamit na tayo ng Excel. So, let's take this as your coefficient matrix A. Okay, so, yung first equation, yan, 7.4, yung constant ni M2. Tapos yung 1.2, yan yung constant ni M3. Coefficient pala, I mean. Okay, so A, this is your coefficient matrix. Tapos yung negative 8, dito natin ilalagay yan sa B matrix. Okay, so remember that your matrix A is your coefficient matrix. Tapos B, ito yung yan, nasa right side, okay? So, dito tayo ngayon sa equation 2. So, we have 1.2, tsaka 5.4. Ayan siya. And then, negative 308 nasa B matrix. Ngayon, X is your set of unknowns, no? This is a column matrix which includes now your M2 and M3. X is equal to the inverse of A multiplied by your B matrix. So, papasok na natin ito ngayon sa Excel. So, yung X, yan yung ating unknowns, which is M2 and M3. And then you have the A matrix. This is composed of the coefficients of equations 1 and 2. For equation 1, the coefficients are 7.4 tsaka 1.2. And then for equation 2, you have this. Okay, yan. You have 1.2 tsaka 5.4. Yan yung equation 2. Tapos, sa B matrix naman, you have negative 8 for equation 1. Ayan. Tapos, for equation 2, you have negative 308. And then, we have here A inverse. So, this is, sosolvin natin to. And then, meron tayong X. Yan yung ating unknowns. So, pasok natin ngayon sa Excel. Okay, so let's say this is A matrix. And then, yan, 7.4, tapos 1.2, then 1.2, tsaka 5.4. Okay, tapos dito naman si B matrix. Then this is negative 8 tsaka negative 308. Tapos dito naman yung ating inverse, A inverse. Okay, so superscript. And then, ang technique dito ngayon, i-click mo yung upper left. So, ito yung destination cells. Dito pupunta yung inverse. Yan. Ano? So, i-click mo yung upper left. And then, you type equal. Tapos, M inverse. Open parenthesis. You now highlight your coefficients. Then, close parenthesis. Then, enter. Tapos, balikan mo yung upper left, then highlight mo lahat. Okay? I-highlight mo lahat yung destination cells nung A inverse. And then, you press F2. After pressing F2, ganyan ang mangyayari. And then, you press and hold Control, huwag bibitawan. Press and hold Shift, huwag bibitawan. Pindutin si Enter, huwag bibitawan. Sabay-sabay na i-release yung tatlo. So, meron na tayong inverse. Next, we will now solve for your unknowns. Okay, so, ayan. Punta tayo dito ngayon sa first cell. I-type there equal sign. Then, M mult. Open parenthesis. M mult stands for matrix multiplication. Okay? So, escape ko ulit. Equal sign. M mult. Open parenthesis. You now highlight your inverse matrix. Yan. Then, comma. Tapos, i-highlight mo yung B matrix. Then, close. Then, i-press enter. Tapos, i-highlight mo ulit yung destination cells nung X. Then, you press F2. Press and hold Control, wag bitawan. Press and hold Shift, wag bitawan. Press and hold Enter. Sabay-sabay na i-release. Okay, so meron na tayong value ng HX, which is actually your unknowns. So, ito yung M2, yan yung 8.4735. Tapos, yung M3, negative 58.92. Okay, so yan ang shortcut para ma-solve mo yung unknowns. Okay guys, so, i-exit ko na tong Excel. Now, let's go back to step 4, which is solving for the reactions. Okay, so ipapasok na natin si value ng M2. So, mag-cut tayo ngayon sa point C, which is ito. Summation moment at point C is equal to M2 ABC as free body diagram. So, remember na si point A, yan yung tapat ni 20 na concentrated load. Si point B, yan yung R1. Point C, yan yung cut section. So, summation moment at C, you have 5R1, positive kasi clockwise, and then negative 20 times 7 is equal to 8.4735. Yan si M2. Ito siya. So, you have your reaction 1. Next, mag-cut tayo ngayon sa kay D. Okay? Mag-cut tayo kay point D. Yan. Dahil meron na si R1, ang unknown natin ngayon dito ay si R2. Ayan. So, ito yung figure. So, summation moment at D is equal to M3, which is negative 58. Okay? So, you have here 11R1. Take note, 11 is the lever arm from point D. Then, positive siya kasi si R1 magkokos ng clockwise direction. Okay? Plus 6R2, lever arm ni R2 is 6 from point D. And then, minus 20 times 13 minus 10 times 6 times 3 is equal to negative 58.92. Okay, palitan nyo na lang yan. So, you can solve here the value of R2, which is 9.08. Okay, so from here, you can immediately solve for the remaining reaction by summation moment at D. Okay, so let's take moment at D equal to M3. So, taking DE as free body. This time, ito naman ang ating kukunin. Meron na tayong moment 3. Reaction 4 na lang ang unknown. So, ito siya. So, we have here 60 times 2. Yan yung concentrated load minus 6R4. Minus in the sense na si R4 magkokos yan ng counterclockwise moment. And yung moment niya ay 58.98. Naging positive kasi opposite direction siya, no? Take note yung 58.92 kapag kino-consider natin yung left section. But this time, ang kinonsider natin ay DE, yan yung right section. Kaya, naging positive si M3. So, from here, you can solve for R4, which is 10.18. Next is you have summation moment at C equal to 2. CDE as free body. Yan. So, from here, you can now solve for reaction 3. Okay? Which is equal to 91.05. And then from there, you can check summation forces vertical equal to 0. Okay guys, so that's it. Remember na ang na-generate natin dito is yung steps 1, 2, 3, and 4. So meron tayong pattern na sinusundan which we can apply to all problems. Also, ang titingnan mo lang ngayon, ang una mong titingnan yung table 20.1. After solving for the moments, you can proceed to step 4 and solve for the reactions. Okay guys, thank you for listening.